Welcome back to the lectures on work and energy. I think in the previous lecture I was trying to look at the collisions. Okay, in totality I'm going to look at. I'm not going to distinguish cases of conservation of linear momentum separately. I'm going to mix up center of mass with this. I'm going to mix up collisions with this. And of course, I'm going to mix up work and it's all part of the dynamics, right? And I think last time I was trying to give you the case of elastic collision, semi-elastic collision, inelastic collision. There is just before, during, just after the collision. Likewise, I tried to distinguish. B, D, A, before, during, after, B, D, A. Okay? Likewise, I gave E, this is 1, this is greater than 0 but less than 1, and this is equal to G. Then I gave linear momentum, conserved, conserved, conserved. In all the situations it is conserved, and your total energy is also conserved. I think the order in the table might be different, it doesn't matter. Kinetic energy is the same but not conserved during elastic collision. Well, this is N everywhere, and obviously N everywhere. P also same thing. N6C, right? Then mechanical energy. Mechanical energy is conserved during the collision. Here in semi-elastic, not conserved. Remember, this also is not conserved. These are the essential things that we come across. Total energy is conserved in all the situations. And kinetic energy is conserved in all the situations, and potential energy, total energy and mechanical energy. You have to do momentum, linear momentum. But people have a wrong notion about this. And so I'm trying to distinguish during, just before, just after. Okay? That is why C for conservative and M for not. They are not conserved and this is conserved. That is the meaning of it. Okay? Now, I think if you have this background, then I will tell you suppose I take one-dimensional collision. Coefficient of restitution is E. Let a body of mass m1 be moving with velocity u1, and let another body of mass m2 moving with velocity u2. Let them collide, say for delta t, and let their velocities become v1, v2. This is 1D. Therefore, E is equal to V2 minus V1 by U1 minus, I told you if it is 2, 1, it should be 1, 2 here. Along the same line, so I need not take dot J and all that. Okay? Why it took vectors here? Possible they might be approaching each other, then one is positive, another is negative. So you have to put that sign, nothing more. Okay? Now, the first thing is, in any collision, linear momentum is conserved. That means, I will write it here. M1 U1, M2 U2, M1 V1 plus M2 V2. Now remember, everywhere I am putting it. Remember, it is one day. Okay? So linear momentum is good. Then you have V2 minus, V2 minus U1 E into U1 minus U2. Now there are two equations and two. You have to find out the expressions for V1 and V2. Now, so this is straightforward. For V2, I can write it as V1 plus. So I substitute. I am removing the arrows for the time being. Is equal to M1 V1 plus M2 into V1 plus EU1 minus EU2. So V1 into M1 plus M2 here. Now this entire thing I will bring on to this side. This as it is. Now this is done, this is done. Now you have plus M2 EU2 minus M2 EU1. Okay? Now I think I take U1 common. So this, okay? I'm not minus. Yeah. Now what are you getting here? Plus this you see. M2 U2 So what do you get? V1 is equal to M1 minus EM2 U1 plus this is V1. This is a very, very, very important result. In 1D collision, you can directly use for all three types of collision. Elastic, semi-elastic, perfectly inelastic. And once you get this, what about V2? So for V2, what do you do? Simply reverse this. Isn't it? So V2 means V2 minus EU1 plus EU2 is equal to V1. So M1 U1 plus M2 U2 is M2 V2 plus M1 V2 minus EU1 plus EU2. Now U1 U2 bring on to this side. M2 V2 is M1 V1. Okay, what do you get? M1 U1, this becomes plus M1 U1. So this term has come, and plus M2 U2, and this is minus M1 U2, and that you are getting V2 into M1 plus M2. So these two are combined. So what are you getting? V2 is equal. I can combine these two. You can see very clearly U1 plus M2 minus M1. This is the second equation. Always remember these two relations. The rest I am erasing. These are extremely crucial relations. I'll write it here for you separately. M1 minus M2 by M1 plus M2 U1 plus m2 into 1 plus e by m1 plus m2 into u2, and v2 is equal to m1 into 1 plus e by m1 plus m2 u1 plus m2 minus e m1 by m1. These two are very, very important relations. All 1D equation only I am talking about. I am trying to get a general for elastic, put E equal to 1. Perfectly inelastic, E is equal to 0. So for elastic, what do you get? V1 is m1 minus m2 by m1 plus m2 u1 plus 2 into y m1 plus m2 u2. Similarly, Vt is equal to 2m1 by m1 plus m2 u1 plus m2 minus m1 by m1 plus m2. This is for elastic collisions. Okay? For inelastic, E0. So, E0. What do you get? V1 is V2. Both you will get same thing. Both the bodies move together. Because it is 1D. Here the line of motion is the line of impact. All the exchange takes place only along the line of impact. But this is not true. This equation you cannot use in 2D. In 2D, what you should realize is that along the common tangent there is no change, and along the common line of impulse they have common velocity. So this is important. Along the line of impact or impulse, both bodies will have common velocity. Is that clear to you? I hope it is. Now, fine. So far, so good. This is of course semi-elastic. Now, one important thing I want to say, laws of K in semi-elastic collision. That means, originally how much? Half m1 u1 square plus half m2 u2 square and minus half m1 v1 square minus half m2 v2 square. This is the function we have to get. Now look at this. m1 by 2 v2 square. This is what I am going to find out as loss. Now, you have to include all these expressions here. You see, m1 by m2, u1 square, minus v1 means all this. Isn't it? Minus v1 square minus m2 square 1 plus e whole square. In a similar way, second expression also you will get. If I am trying to simplify the first expression, write that as well. M2 by 2 U2 square minus M1 plus M2 whole square U2 square minus this is U2 square likewise. I hope this is clear. Now M1 plus M2 whole square, accepted these two is common, I'll remove that and M1 by 2. Now U1 square into M1 plus M2 whole square. Come M1 square plus M2 square. 2 M1 M2 square U1 square minus this U1 square is common. So minus M1 square plus E square M2 square minus plus 2E M2 all in U1 square. Okay, U1 square. And then I can also write this part for U2 square. So this is as it is, M2 square, 1 plus E whole square, M1 plus M2 whole square, U2 square, plus M2 by 2 into M1 plus M2 whole square. In this and this I will combine. So U2 square into M1 square plus M2 square, 2 M1 M2 minus M2 square minus E square M1 square plus 2E M1 M2. All this has come with the U square, and that leaves with minus M1 square 1 plus E whole square by, because this outside by 2 U1 square. Here of course we need not keep that because that part has come out. I just example little lengthy, but the ultimate expression is very, very important. Then what I will be doing, 1 by 2 M1 plus M2 whole square is common in all the things. So just forget about that. The rest only we are going to do. Now, if you see U1 square, what are all the factors for U1 square you have? M1 into M1 square, M1 cube plus M1 M2 square plus 2 M1 square M2. All this has come. But luckily, this is getting cancelled. Okay? That is getting cancelled. So cube you need now to bring in. I think M1 M2 square plus 2m1 square m2 minus m1 m2 square e square plus 2e m1 square m2. So this whole part I have written. Then u1 square is minus m1 square m2 and minus m1 square m2 to 1 plus e whole square. So 1 plus this term and the remaining. You have added. Now u2 also I will do the same. 2 square. Now m2 square m2 square. So you have m1 square m2 plus 2m1 m2 square. This is over, and minus e square m2 m1 square plus 2e m1 m2 square. So all these terms have come. And then u2 square minus m2 square m1 into 1 plus e whole square. So these are the terms that I have brought with me. Right? Now, this is m1 square m2. You can see. Here you will get plus 2e minus 2e. That gets cancelled. So you have to now look at m1 square m2. We will do that one by one. I'll do that here for you. This factor we will keep it separately. u1 square m1 m2 square plus 2m1 square m2, okay, minus m1 m2 square e square. Okay, these three are over. This and this gets cancelled. So that leaves you with minus m1 square m2 minus e square m1 square m2. There are three terms, one term gets cancelled here. That is u1 square. Could you see anything common in any one of these things? Maybe this and this. Okay, that will go, and once you get it, so m1 m2 square plus m1 square m2 minus m1 m2 e square, m1 m2 e square, m2 plus m1. This is what I am going to get there. And here m1 m2 also I am getting common. m1 m2 m1 m2 plus m2. This also you get m1 m2 into m1 plus m2 into 1 minus e square e1 square. This is what you are getting there. This, the first term reduces to that. Okay, and here also you do the same thing. 2e m1 m2, that also gets cancelled, and you will get what do you get here? minus e square m1 m1 square minus e square. M2 square. Okay. Now m1 square into plus 2m1 m2 square minus e square m1 square into 2e m1 m2 square. 2e m1 m2 square will get cancelled. So you get minus m1 m2 square so this becomes 1 1 2 3 4 2 m1 so minus e square left plus 2e. That's right. 1 gets 1 2 3 1 2 3. Okay, what am I getting? You can see, combine these two, m1 plus m2, and this is minus e square m1 m2 into m1 plus m2. So this is same thing, m1 m2 into m1 plus m2 into 1 minus e square. You look at that, absolutely similar, but this is a combination of u2 square so of m1 m2 1 and 2 by that m1 plus m2 whole square into m1 plus m2 so into m1 m2 by m1 plus m2. You should get u1 minus u2 whole square. Now, once you work it out, I think the simplification is a little clumsier. You will not get like this. You will get half m1 m2 by m1 plus m2 into u1 minus u2 whole square into 1 minus e square. This is what we call as loss of Ke in any elastic collision. Now, the derivation will have to be done, I think, little more neatly. Then you are going to get this solution. What is this? So this is loss of Ke in 1D motion. 1D semi-elastic collision. is a very, very important relation. You get it, you can find out u1 minus u2 whole square and into 1 minus u square. Suppose u1 and u2 are opposite. Loss is equal to half loss would be like that. Yeah, this way. That's okay. Alright? This is how you have to use that particular relation. Okay? So, well, obviously E is 0, then you have maximum loss. Loss is maximum, so you can try with that. E is equal to 1. No loss of K. That is elastic collision. There is no loss of K in perfectly elastic collision. That's what you should remember. Okay, maximum loss is in this. There is a partial loss in semi-elastic collision. This is how one has to understand. There is a loss of Ke, and then you have final expressions for those two. I already gave you that V1, V2 expression, loss of Ke. This is all you get in one-dimensional collision. Okay? Right. Now you have to apply. For example, special cases. V1, M1 minus M2 by M1 plus M2 U1 plus 2M2 U2 by M1 plus M2. This is for elastic collision. And for semi-elastic you get M2 into 1 plus 3 by, that is semi-elastic. Okay? Now in a similar way you have 2 minus M1 by 1 plus U2 U1 into M1 into 1 plus 3 by sigma U2 into 1. This is what this. Okay? Now U2 0. M1 is equal to M2 is equal to M. Identical bodies colliding, one-dimensional collision, body is moving and colliding another body at rest. What's it you're going to have? Put U2 0, the second term will go and the first term will go. So, V1 you will get it as 0, V2 you will get it as how much? 2 gets cancelled, U1. That means this body comes 1, 2, then 1 remains here, 2 goes. 1 comes to rest, 2 goes. Now what about this here? This gets cancelled and M1 is equal to M2. Then what do you get? V1 is equal to 1 minus E by 2. U1 V2 is equal to that's how you get semi-elastic. This is how you are going to have. Clear? If it is perfectly inelastic collision, put U0. The body will go with U1 by 2, V1 by 2, both are same, and they go. Now, the one has to distinguish what is that collision, and all the masses same, and that's how you can compare. And it is a very fairly simple thing that you can easily find out. Identical properties first place. Now, if I say M1 is far greater than U2 0. M1 far greater than M2 means what? M1 plus or minus M2 is equal to M1. It makes no difference. 2M2 by M1 plus M2 is nearly 0. Why? The very small term is a huge term, so 0. So what do you get here? You see, V1, M1 is far greater than. So M2 is anyway 0, M2 is nearly 0. So you get V1 is equal to U1. That means that heavy body continues to move with the same velocity. And what about V2? V2 is equal to this and gets cancelled. This is a very interesting result. Now, see, there is a huge body hitting a very small body. 2, 1. Now, this will move with twice the velocity of U1, whereas this continues to move with the V1. That means after the collision, this is U1, that will go with 2U1. If you come to this, what do you get? U2 as usual 0. So here also you get V1 is equal to what do you get? This part is 0, M1 is 0. So the heavy body continues to move in that. What about that second body? M gets cancelled. Obviously, V is equal to 1, V2 becomes 2U1. You will see that. So this is the case in the semi-elastic collision. This is the case of perfectly elastic collision. We'll continue this up.